I forget to do that. So look at the label. You build conversion factors out of equivalence, right? But how do you know which one to use? If there were 6 of them I could have made, how do I know which one to use? That's the easy part. What label has to go away up here? I put it down here. Grams of sulfur, right? And then what label would you like to replace it with? Atoms of sulfur. And then I go over here and I find how many grams of sulfur. There it is. Oops, right here. 32.06 grams is the same as what? 6.02 times 10 to the 23rd atoms. Huh. Now, if the labels, and you actually get points for doing that right there. You see that? And now, what's the only label left? That's what I wanted. That's when I pick up the calculator. That's when I put equals. And then the last little trick, if it's in a numerator, you're going to multiply by it. If it's in a denominator, you're going to do what? It's just the opposite. Divide. So here's what you do. Ready? Everybody have a calculator? Let's do this one more time. We're going to look at the calculator and make sure we know how to use it. Please don't do factorial without a calculator. Does anybody not have one? I have one extra. Anybody have one? You need one? Over there in my bag, that blue bag over there, next to Isabella. I came late to class and don't have a calculator. Okay, all right. Okay. But you're ready to learn though, aren't you?
Oh, yes.
Oh, I thought so. Okay. All right, ready? Watch now. You do have to be careful because remember when you put exponents, the calculator thinks you have a really long exponent. You got to tell me I'm done, right? So watch. 50 times 6.02 times 10 to the, and how do you say to the, what's that button the math teacher teach you to do a superscript, an exponent? You say, all right, 50 times 6.02 times 10 to the, what? 23. Now look at your calculator. It thinks you're going to add some more exponents, right? No, I'm done with that. So arrow, use your arrow key and arrow over. Now say divided by 32.06. And then put enter. Now are you getting this answer? Did you know the calculator, when it gets to a really, really big number or a really, really small number, it automatically puts it into scientific notation? Now, I want you to learn how to round these off. When you round to 3 sig figs, you do look at the fourth one, don't you? Is everybody getting 9.39? Does it say E? Do you see E somewhere? E means times 10 to the. So you should have got 9.39 times 10 E, or times 10 to the 23rd. Is that right? You gotta stop me if you're not. If you want to be certified, you gotta know what you're doing. All right, that was a type 1 problem. Now, let's go to the next page. Here is another type 1. Type 1 simply means you only need one conversion factor to get this problem done. 150 pounds equals how many kilograms? I don't know. The rest of the world knows how much they weigh in kilograms. How come you don't? The rest of the world knows. You go to Brazil, how much you weigh? Well, blah, 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 kilograms. Go to Russia, how much you weigh? Blah, 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 kilograms. They know it. The whole world does. You don't. So if you want to do your own weight, you can put it in here. Or you can use the one I had, either one. 150 pounds over 1, that's my given. I automatically put pounds down here. Automatically, because it has to go away. And boy, it'd be nice if I could change it to kilograms. Oh, thank you, Mr. Feeney. You happen to give me the exact equivalent I needed. Isn't that right? Now I can make how many conversion factors out of that? Zach knows. How many conversion factors can you make out of that? Watch. This is A, and this is B. How many conversion factors can you make out of this statement? How many? No, not 6.
He said 2.
What is it?
He said 2.
Oh, 2. I am sorry. I hate the mask. I hate him. Okay, sorry. You are right. You are right. It's A over B, or you could use B over A. Is that right? How do you know which one to use? That's easy. What label is up here has to be canceled out? Pounds. Then put pounds down here. And then put kilograms here. And then, I got the numbers. 1 goes with kilogram. 2.2 goes with pounds. I know you can't believe it's this easy, but here's what happens. The only label left is what I want. That's when I press equals and I pick up the calculator. 150 divided by 2.2. I got it. I'm done. Yes? Okay. Let's do type 2 now. Remember the 5-hour-old baby? I just made it up, but it's kind of fun. Now, many times you just don't have the equivalent you need. You can't get it done in one thing, right? So what I do is I just keep building more and more conversion factors till I get close. An hour is kind of a small time unit compared to a century, isn't it? So I got rid of hours and changed it into days, changed days into years. See, when these canceled out, I got days, right? When days canceled out, I had years. And when years canceled out, I had centuries. As long as this equals this equals that, and this equals it, all those are conversion factors, aren't they? You have to know how this works, and then you'll understand it. And now, how we do it in the calculator? I know it's right because guess what? The only label left is centuries, and that's what I want. And that equals that, that equals that, that equals that, and that's a given. It's got to be right. Calculator time. Ready? 5. What are you going to do now? What are you going to do with that 24? Divided by 24. What are you going to do with that? It's in the denominator. What are you going to do? Divided by 365.25. What are you going to do with that 100? Divide by 100. Now you press enter. Now again, I want you to learn how to round it off to 3 sig figs. So look at the 4th sig fig to see if the 3rd one stays the way it is or not. Is everybody getting this? Not? 5.70 times 10 to the... Don't forget that E. That E is important, isn't it? And then you have to have a label. Now, if I give you 10 points for this problem, okay? Let's pretend you have a quiz and you get 10 points for that problem. You get 2. 2 for the answer. That's all. 2. Guess what you get for that? 8. I've had people get all this right, and they punch in the calculator wrong, get the answer wrong. They still got 8 out of 10. I want to give you 8 out of 10 for showing you know how to do factor label. I'm sorry you pushed the wrong button, but you know how to do the problem. You get that? I'd like you to do both. Know how to set it up. Don't push the wrong button. All right, let's go to type 3. Type 3, be careful. Whenever you see MPH, we know what that stands for, miles per hour. How do you write miles per hour? You do not write it 60 MPH. 60 miles, what's per mean? Divided by. Do you know that? Do you know that per means divided by? Okay, so 60 miles, and the abbreviation for miles is not M, it's MI. 60 miles per hour. Ever got it? 60 miles per hour. So that's my given. Now what's different? The given has a label here and here, doesn't it? Oh, I'm scared. I'm scared. No. Just take care of one at a time. Just pretend you only see one of those. I got to get rid of that hours in the bottom. How do you know you have to get rid of hours in the bottom? Because my final answer has to be in what? Meters per what? Help me out here. Meters per what? What's S? Seconds. All right, ready? How do I get rid of hours in the denominator? Multiply it by a conversion factor with hours in the numerator. Get that? Here we go. What do you know about hours and minutes? I got to get closer to seconds, don't I? What do you know about hours and minutes? 1 hour, is that equal to 60? Yeah, then I can use it. Cancel. See, I'm factoring out labels. Now my answer is in miles per minute. Not done. You're not done. Now get rid of, how do you get rid of minutes down here? You have minutes up here. 1 minute is 60 seconds. Now guess what happens here? Uh-oh. What unit do I have in the denominator? Yeah. I'm halfway done. I'm halfway done, aren't I? Now what? This is where the bell rings. Help me out. Okay? Engage. Engage a little bit. What am I do here? I'm in miles per second. I'm not done. What do I have to get rid of up here? Everybody say it. Miles. So I put it down here, don't I? What would you like to replace it with? Meters. Darn. How am I going to do that? What if I don't tell you how many miles equals how many meters? What if I tell you this? I can use that because guess what? English unit, metric unit. So what do I need to do? If I want to cross over from the English system to the metric, I got to get down to inches, don't I? How do I get down to inches? Somebody take me through this, all right? Who could do this? Danny, you can do it. You can do it. I have confidence in you, ready? Tell me how to get rid of miles and get all the way down to meters. I'm listening. Go. I'm not even going to put any numbers in here. You know anything about miles and what else?
Miles.
What do you know? Miles and what? Remember, you got to get down to here eventually. You don't know miles and inches, do you? What do you know?
Miles and...
Now, you know what? If you don't know this one, I'll give it to you. Does everybody know that 1 mile is 5,280 feet? Does everybody know that? I'll give it to you. I'll give that to you. All right, go ahead. What are you going to put here?
All right, so you put 5,000 on top.
5,280 on top. 5,280 feet equals?
1 mile.
Now, where do I cancel?
You cancel the mile.
Ah.
And then...
Now you're in feet per second. Not done. Not done.
Then you move to the right, and you put feet on the bottom.
Yes. Yes. Yes.
And then you do inches on top.
Yeah, we're getting there.
And
Tell me.
1 feet equals 12 inches.
Okay. Cancel. You get points for canceling out the units with a single line, okay? Daniel, you're in inches per second. Are you done? Inches per second. Are you done?
No.
No. Keep going.
And,
Can I get in that metric world?
and then you put an inch on the bottom.
Yes.
And then on top you put 2.54 meters.
2.54 centimeters equals 1 inch. You're right. Boy, you're getting close. You're almost done. You're in centimeters per second.
And then
Now the next one, Daniel, I'm not going to give it to you because it's powers of 10.
then you go 1 centimeter on the bottom.
Well, I don't know if it's 1. I am going to put centimeters, but I don't know if it's 1. Don't automatically put 1, okay? I know centimeters. See, is that 1? That wasn't 1. We don't know if it's 1. In this case, it happened to be 1. So we say centimeters on the bottom. What are you going to put here?
You're going to put
Meters. Isn't that, look, if I get to meters, I'm going to be done. Now, you tell me what you know about powers of 10. So many centimeters equals so many meters.
1 meter equals point.
Well, some people, you know what? Some people know that 1 meter is 100 centimeters. Do you know some people do this in their brain? They'll say 1 centimeter is 0.01 meters. Is that what you're getting ready to say?
Yeah.
It'll work. Yours will work. This will work. As long as this number here is 100 times bigger than that, it's going to work. So I don't know which way you like that. I'll do it this way for right now. But if you wanted to put 1 centimeter equals 0.01 meters, go ahead. It'll still work. Now, guess what? Meters per second. It's time to get the calculator out. All right, let's everybody do it. I want you to calculate it and round it to 3 sig figs, scientific notation, and then I want you to look somebody, neighbor, find a neighbor, and show them your answer and see if you match. All right, let's find this answer. 60 miles an hour equals how many meters per second? 60 miles an hour, how many meters per second? So write it down somewhere and show somebody else in the room. So here's what I got. What did you get? Because if you're punching that number in the wrong place, we need to find that out now. And let's say right now you're not sure how to put in a calculator. I want to help you now.
What do you put in?
Okay, start with 60. And then this is in the bottom, isn't it? So you say divided by 60. And see that guy, he's in the bottom? Say divided by 60. And he's in the top, so you say times 5,280. And he's on top, so you say times 12. Times 2.54. And this guy's in the bottom, isn't he? So you say what? Divided by 100. And then you say enter. Check with your neighbor. You're going to see if you can put it with 3 sig figs and scientific notation. Now, I haven't done this one, so I'll have to assume that if you guys are matching, you probably have the right answer. But now, scientific notation, wait a minute, scientific notation, do you guys remember how to do scientific notation on your calculator? Wait a minute. Did you guys know that if the number is really, really big, it'll do it by itself, but if not, you have to do it? How do you make that calculator always give you scientific notation? What do you press? Mode. And right now it's flashing on normal. Use your arrow key and go over to SCI. That means scientific notation. And then press enter. Now every problem you do from now on will give you scientific notation. When you go back to your regular math class, press mode, go back to normal, and you'll be okay. All right. You get matching? Did you guys match back there? Okay, so tell me what you got. Well, I already know that's not in scientific notation, but all right. So I already know you'll miss at least 1 point because it's not in scientific notation. So you want to put in scientific notation in your head, or you want to let the calculator do it for you? 2.68. The next number is less than 5 after the 8. The fourth number is less than 5, right? Okay, so 2.68 times, the E means times 10 to the what? That's right. Is that what you got? Madison, you get that? Isabel? Okay. So if we know how to think our way through the problem and we know how to put in the calculator, we're getting close to being ready to be certified, aren't we? We're not there yet. We have to practice. Okay. Well, anyway, what I want to do is I want to show you the hardest ones to do. But if you'll listen to me, I'll show you exactly how to do the hardest ones. I'm glad that I think a lot of you could be certified, almost ready for type 1, 2, and 3. But let's do a type 4. And I'll tell you why it's a little bit harder. But I'll try to show you a way to do a hard problem easy. Nobody ever showed this to me when I was in high school. I wish they would have. They didn't. Let's do type 4. Okay, now, I want to show you something here. You have to be kind of careful here because you see this and you said, I'm done. I know what the answer is. And a lot of you are going to say, the answer is 12. And you are way, way off. And I'll show you why you're way off in just a minute. Because I'm going to show you a little trick here. When I see the word foot, if I see the word meter, if I see the word centimeter, if I see it written like that, I know you mean I'm talking about some kind of a distance. And we have different words for distance. The length of something, the width of something, the height of something, the circumference of something. Those are all distances, aren't they? That's why you might see centimeters after it, millimeters, meters. But listen to me. This is something you don't understand. When you see a distance unit and it's squared, you are not talking about distance. You are not talking about distance anymore. Here's what you're talking about. These are like distances. When you say a square foot, it's this big, it's a square. And it's not one-dimensional, it's two-dimensional. And what you were talking about is not distance anymore, but area. Hey, how long is a square meter? That's stupid. It's not a square meter, it's not a distance. A square meter is like this table is about a square meter of area. Now it is true, if I had 1 meter long and 1 meter wide, You multiply length times width, you get 1 meter squared, also known as 1 square meter. But just understand, these are not distances anymore. And what if you see this? Cubic feet, cubic centimeters, cubic meters. That is not distance. That is not even area. It's something that's in the third dimension. It's three-dimensional. This is three-dimensional, isn't it? And what do you call that? It starts with a V. What do you call, if you measure cubic feet, cubic inches, cubic miles, what are you measuring? Say it again? Yes. You see that? Now, if you understand that, you'll understand this problem is not what you thought it was. If you thought it was 1 foot equals how many inches, you're right. That is 12. I promise you, though, that a cubic foot does not equal only 12 cubic inches. So I'll show you how to do this problem, right? Let's write down the given. Now, I'm going to be a little tricky, okay?
We can't see it.
Okay, I'm sorry. Too high? Too low? Okay. Thank you. Ready? I'm going to be tricky. If I was in math class, did you know your math teacher probably taught you this? Did you know that x cubed is x times x times x? I bet they taught that. So why is it that you don't understand that a foot cubed is a 1 foot times foot times foot? Did you know that? What's a foot times a foot times a foot? A foot to the third power, also known as a foot cubed, also known as a cubic foot. Okay, so now by the way, when I say cubic foot, let's make the problem a little, well, okay. Do you understand? I'm not cubing the number, I'm only cubing foot. So if this had said 8 cubic foot, would I say 8? No, 8's not being cubed, only the foot. So here's my given. Okay, now we got that down. Now, what do you have to cancel out? Watch what I'm doing here. What am I supposed to cancel out? Not feet. What do I have to cancel out? Foot times foot times foot. What's that? It's not a foot. What's it called? What's a foot times a foot times a foot? A cubic foot. I have to cancel out all 3 of those, don't I? Now, let's go over here. You don't know how many cubic feet equals how many cubic inches. You don't. You don't, honestly. I'm not trying to say anything bad. I don't. I don't have it in my head. You don't know that. But do you know how many feet equals how many inches? Then I can use it. If this equals this, if 12 inches equals a foot, then I've at least canceled one of those, haven't I? Well, what are you going to do about the other ones? I got to do it again, don't I? 12 inches equals 1 foot. I'm still not done, though, am I? Don't I have to cancel out one more foot? 12 inches equals 1 foot. Huh. I just got rid of cubic feet and replaced it with what? Don't say inches. I replaced cubic feet with what? Cubic inches. Isn't that right? What's an inch times an inch times an inch? Isn't that an inch to the third power? That's a cubic inch. And guess what? That's what I want. If the last unit left is what I want, I press that equals, I put my label here, and I pick up the calculator. Let's do it. Pick up the calculator. Okay. I will tell you that ones don't make any difference. You multiply things by 1. You divide by 1, doesn't matter. We don't have to put those in there. So just start with 12. 12 times 12 times 12. Okay, what's the answer? Check with your neighbor. See if you get the right answer. And I would like you to put in scientific notation. I would like you to round up to 3 sig figs. Let's see if you remember how to round. Let's see if you know how to put in scientific notation. Okay, show your neighbor. If you don't get the same, you talk to them and say, what? What? Wait, 1.73? time, isn't it times 10 to the something?
Yeah, I said that.
Okay, what do you got?
1.73 times 10 to the
10 to the what?
third.
Okay. Now, whether you like it or not, do you know how many cubic inches are in a cubic foot? Here's a cubic foot. It's a cube. Here's a cubic inch. How many one cubic foot equals how many cubic inches? If I take this out of scientific notation, 1,730. Not 12, 1,730, or 1.73 times 10 to the third. Yes? That's kind of the hardest kind of problem I can give you. I will tell you, I'm going to go ahead and give you, there's two things that I have. What I'd like to do, let me think about this. If I give you the homework now, you can at least get started on it, but what I don't want you to do is I don't want you to go home and have somebody help you with this. I'd rather you struggle with it a little bit, and then you come back at the beginning of class tomorrow. You said, I just couldn't get number 4, and I'm going to help you with that. You get it? And then you'll turn your homework in, and I'll help you with some of the errors you made, and then I'll give you the certification. So then what'll happen is you'll have the rest of the period tomorrow to do 5 factor problems. And all you do is I'll walk around, you can use your notes, and all I do is, yeah, you got that right, and that's your goal. Try to be certified by then. If for some reason you're not quite certified, then on Friday you'd finish your certification, and then you would take the quiz. So the quiz, I think there was like 4 problems on it. Yes?
If we get it wrong, do we just like fail it? Or, like,
What I'd like you to do on your homework is before you turn the homework in tomorrow, you should know if something didn't seem right. If something didn't seem right, so I got stuck, and I'll try to help you get unstuck, and then you'll finish the problem. Okay? And like right now, I'm going to hand it to you, and I'll just walk around the room. So maybe I could also tomorrow, maybe the first 10 minutes, I'll let you sit here, and I'll just walk around the room and help you get past any bumps. How about that? And then you won't turn it in until you had a chance to, but don't come here and not have them done. You won't be able to get them finished. All right, let me go ahead and give that to you. Okay, sorry. Oh, wait a minute.
Yes.
Okay, they look like this.
It's right.
All right.
But you couldn't do what I could do. I'm sure you were cool. Hey, Dad, you match shirts? Let's go back to labeling, and I can do it now. I'm certified.
I tell you what, I give everybody one of those. That's a review sheet.
I have a note from Mr. Ping. I mean, my little wish.
All right, the first sheet you're going to get, Isabella's giving you a sheet, and it actually is a review. It actually reviews type 1, 2, 3, 4, 5, and 4, and it also shows a mole problem at the bottom. Now that would be real handy to have with you. Now this next one is the one I like to do for homework, and I think if you could go home and do as many of these as you can. Let's say you just had 2 of them you had trouble with. 10 minutes would be plenty enough tomorrow to fix those 2. Then what you're going to do is start the certification process, and you say, well, I need to go that again. And all right, so let's try number 1. Ready? Let's do it together. 120 pounds equals how many kilograms? Now, I get to choose how many hoops you're going to jump through. I want you to jump through 1 hoop. And what's it say there? You are only allowed to use 1 conversion factor. Now, flip this paper over, and go down where it says mass. Go down on the back at the second column. You see where it says mass? What is 1 kilogram equal to? 2.2 pounds. Okay, there we go. There's your equivalent. You're ready to start. I'm going to walk around the room. What are you going to do first? If you didn't write 120 pounds over 1, you're not paying attention. Everybody have that? 120 pounds over 1. If you didn't multiply by a conversion factor that has pounds in the bottom, you're not paying attention. And it just so happens that I gave you the perfect equivalent, so you can not only have pounds in the bottom of the conversion factor, you can have kilograms on the top, can't you? Now don't mess up the numbers. Don't mess up the numbers. How many pounds equals how many kilograms? Put pounds down there. You know what pounds. You know pounds goes down there, don't they? Put that right now, right away. Put pounds. You know your conversion factor has to have pounds in the bottom of it, doesn't it? And the top's going to have kilograms. Now, make sure I can see your labels, and make sure you cross them out with a single line. A single line. And don't forget your label on your answer. Now, the rules, the directions say you have to round this off to 3 sig figs and put it in scientific notation. So, can everybody make sure that you're in scientific notation, 3 sig figs. Is that what you got? Okay, I'm gonna check somebody else. Everybody's done yet? Almost? Almost? You have the first one done? Okay. Now instead of putting E, you're gonna put times 10 to that, okay? 2 people look like they have the right answer. Oh, where's your? Okay, now I'll tell you what. If you don't put labels, you'll get completely lost. Completely. Put pounds here. Put pounds here. And what are you gonna put up here? Okay. Okay. Now if this is a 10-point problem, we've already missed a bunch of points. You have no label here. What's that? Okay, that looks good. That looks good. That looks good, except you don't have a label. Put a label right there. What's the only label not canceled out? Put a label right there, okay? Remember, factor labels, the labels are as important as the number. Okay, now, do this thing, yeah, they get 5.45, you get 5.5. Yeah, that's it. They got it. Nice. All right, the answer to number 1 was 5.45 times 10 to the what? First, what units? Kilograms. Okay. So see what, here's what you do. This always comes from equivalents. It never comes from the problem. It comes from things that are equal. 1 kilogram equals what? 2.2 pounds. So you already had pounds here, but 2.2 here. See that? You know what? When I first learned this, I did the same thing you did. No, you have 120 here. See, the given has 120 in it, right? But I won't use that 120 again, will I? But the conversion factor is going to have 2.2 and 1 in it, isn't it? And once you learn how to do that, you'll get them all right. And you do this, don't worry about ones, this divided by that. Okay, looking good. All right. Do number 2 now. Okay, let's try it. So get 60 divided by 60 divided by 60. No, see, I'm going to do it real fast, so the ones don't matter, okay? So 60 divided by 60 divided by 60. So times 5,280 times 12 times 2.54 and then divided by 100. What was the answer to that one? 2.68 times 10 to the first. All right, let's try it again. Okay, clear your calculator. Ready? 60 divided by 60 divided by 60 times 5,280 times 12 times 2.54 divided by 100 5,200. Okay, good. Found it. Keep going. Now, really, you can get another problem done before we leave today, right? If you just trust the labels, make sure the labels make sense, then the numbers will make sense when you put them in the calculator. Now notice at number 2, I force you to say you can only use one conversion factor. So you go to the back, go where it says energy, find energy. And wow, there it is. No wait, where's herbs? Where are you? Energy. Oops, am I in the wrong place?
Attention DR students, student drivers may now be dismissed. Student athletes need to stay in the classrooms until rehearsal begins at 3:15. Also, students that had retakes done for pictures can pick up their retakes in the DR office. Thank you.
The herbs are underneath herbs. Anyway, that list right there tells you who actually, officially, they know that you either ride or you drive. So, you look right there, we have Julie, they're gonna leave right now, and then we have, hey, Zach, and that's it. You got that? Yeah, we have to wait. Hang on, so what we do is, those 2 people can leave. Now, if you want to tell the office that you actually are a driver, they don't know. If they know you're a driver, your name's on it.
My name is on the list in my class yesterday.
It was? I think you go to the office and say, my name doesn't show on my list.
Ms. Strickland sent it. Yeah, I already talked to Ms. Strickland and Ms. Reardon, so they gave me. Ms. Strickland said I did it.
What did they tell you about not being on the list?
She said that my name was on the list.
That list right there?
That's the old list. It's been
Okay,
updated.
so there's a new list?
Yeah, I think they did.
brother submitted a report.
All right, I'll tell you what, all right, if you know your name's supposed to be up there, I'll get the new list. I'll get the new list. Thank you. I lost my herbs. Where's my herbs at?
It's like,
There's an herb. What about herbs and jewels? There it is. That's the energy. There it is. Yeah, 78 energy. I was looking at mass energy. Yeah, 78 energy. How'd you do? How'd you do? Find herbs? So that's a given. And now there's no label. No label here. What's that supposed to say? It's supposed to say 1 joule is equal to like the herbs there, and then you get full credit, and the herbs there, and the herbs there.
That's what I got.
Now the first 2 are Celsius, and then it gets a little harder, because this you're gonna have to put a bunch of them
It's
together.
just 10 million.
And this one's a little harder, because you have to use these.
I can do it.
It says you can only go 1 conversion. You know, there's 6 of them could be built.
Is that not the right
Only one.
conversion?
I mean,
Is it not
And
10
then there's
million?
a little
it's
harder.
just being like.
Here's the miles per hour thing,
Oh.
and there's the other one that has cubic miles.
So,
Those are
it's
gonna be
just
the hardest
$1
ones.
million too.
Yeah, that's what I got.
If you allow the labels to see, without writing labels, you're not catching on, so.
I'm just trying to get the math part.
Don't do that. Can I tell you, can you trust me on this? If you leave the math alone, if you make sure the labels make sense, the math will work. Because I'm not giving, if I give 10 points for this, and you get the answer right, first of all, it's not scientific notation, but if you get the answer right, you don't show factor label, you only get 2 out of 10 points.
So the actual like official answer is the scientific notation.
Yes. So now, but you also out of 10 points, you get 2 for that, 8 for this. So So if you start showing me no label, you have to label, you miss 8 points on the way. It's not math class where you get to, everything to answer.
I just had a question about, like, the electrons, the equations.
Okay.
I think I know how to do it, but I just wanted
There are a couple of questions here, probably should cross out because I know one of them doesn't make any sense, the way he wrote it. There was some kind of a miswriting of it. And another one, okay, go ahead.
It's like the Leo curve.
Oh, that, okay, that's not very much. So what is this one? This, the lead 2 sulfide? Let's balance, okay, let's balance and ready to go. Yeah, let's try decomposition. I know that water decomposes into hydrogen gas. Oxygen gas.
So that used to I like the concept of
And so decomposition is redox.
understanding how
So what I know they're not redox, it's double replacement. And double replacement's either acid base or
the greatest teacher of all time.
Attention DR students, carpool has now begun. If your name is on the list, you may be dismissed. Again, if you have picture retakes, you can pick those up in the DR office. Thank you.
It's not combined with another element. Now, let's do the redox. So if we lose negative electrons, we become oxidized, we become more positive. So who became more positive? Bye. Think about number one. Bye. Okay. So write one, I like to write one number, so that's my, and then you go back and fix the number, okay? Each option went from one. So it says, what minus 2, put an arrow, the Leo that electrons will be produced. But I don't know where you go from 0 all the way up to -2 to 0. Not add. Even though you say plus, you actually lose, you produce this and this, you produce 2 electrons that are gonna be taken away. Now that's what happens to each oxygen, right? Now we go up and fix everything. Now this is balance. How many oxygen did you really start with? It wasn't diatomic oxygen, was it? No. And what about this? How'd that end up? Okay. And I bet it wasn't 2 electrons now because you said each, okay, put a 4 there. Now now finish the other, do the next one. And do one atom at a time, then we can fix it. If you become a chemist, there is a little way of doing this. I don't do that right now, but you're smart, so you'll figure it out today. One. And I gotta fix the numbers. How many? Right. That was a total of 4 though, wasn't it? Yeah, because that's actually 4, but you said each hydrogen had to gain 1, but now you got 4 hydrogens, so we can do that. Yeah. And then, it really did end up as diatomic hydrogen, but that's good because it's still 4 hydrogens and 4 hydrogens, right? And then you always want to see if this,
Can we do one that has like,
I can make them up, but if I find one that's already made up,
there's a,
yeah, I'm gonna look here. Because I know these are really, that's an easy one. Find one that has coefficients in it. Okay, that's hard. Are you ready? Okay. keep mixing, the ion equations with these, and I don't wanna do that. Give me a paper. All right.
Yeah, I know last Lena even went to her mom.
Single replacement.
So if it's not everything except for decomposition.
No, double replacement.
Yeah, double replacement. You can do everything.
Right, because this is decomposition, and you see things change in their oxidation state, and the driving force was somebody gained and somebody lost electron. Let's do Let's do that. That's a single replacement. You have a non-metal, and I kick out a non-metal. Very balanced. What's the sign? Oxidation states. Now we have three elements. Maybe all three are involved, or maybe only two of the three are involved in redox.
So,
He became more positive, yep, oxidized. Each oxygen had to lose two, we had two oxygen, that's four, and that was diatomic, that was not. Okay, go ahead. It's interesting, lead never did change, so it was not involved in redox.
But you have to get it diatomic to be.
Four.
So do you multiply these numbers
Yeah.
together? And then you multiply them together and then.
These are actually four fluorine atoms involved, but it happened to be, in this case, two diatomic fluorines. That's still four of them, though.
Just say like it was.
But now, what about this? What form were they in here? They were not, that's not diatomic fluorine, that's not compound. So it's really, 2 times 2, oh. Very match. You have 4 fluorines here, you have 4 here, because that's it.
Yeah, that's it.
No, that's not diatomic fluorine.
Oh, it is?
You know why? Because it's not fluorine. That's lead fluoride. It was just the element fluorine, yes. See, that's not oxygen, that's lead oxide. So here, you actually had, if I had to draw it, it would look like this. I'd have this ion, and I'd have one of these attached, I'd have one of these attached, and that's one of them, and now I draw it again. Because you said there were two
have, yeah, so you like that, like say there's
Wait a
a.
minute. This is, okay, okay, that'll work, so you have that now. But maybe in the actual balanced equation, that might be in the form of, what if it was like this, FEO? FEO would be plus two minus two, so there's one of them. But what if it was FE203? What if it's FE203? Okay, then it'd be how many? Sorry, let's do it up through that. What if it was like that?
Carpool is now over. Have a great afternoon.
6 O minus 2.
But so say, yeah, so say this is a two type.
We could do that, like, let's try it, it's like O2 plus iron yields rust, and rust is Fe2O3. Now that's synthesis, but it has to be redox for the synthesis, so let's balance it first. So, okay, now do your oxidation stage, you got an oxidation stage.
Iron,
Yes, okay, now go ahead, let's do, who got, oxidized? Okay. Now, metals likely get oxidized a lot. Yes. Yes, because that's really 2 iron ions, and you have 2 times that, 4 iron ions. That's right. And that doesn't look very good. Okay.
We have to change this, to be 4 times 3 instead of.
Yeah, that's it. The next one. Okay, so let me say, that's correct for each oxygen, but now we gotta fix it. 2, no, you got 3 left. No, no.
Oh, that's only a
That's just the element oxygen, isn't it? So you have 3 diatomic oxygen. There you go. Change that electron. You might have changed the electron because that was for every one. You might as well change that right now.
Because it did,
Right.
3 times 2.
That's right.
And then
There's
there's
6. Each of them had 2, you said.
And then there's,
Is that the electron?
yeah.
Do the one of that.
And then,
Ah, yes.
oh,
Yes.
that makes sense.
Remember, it's only when it's in just the element oxygen, it's diatomic. This is not the element oxygen, that's the compound. Iron trioxide.
Okay.
That was good.
So we need to know,
Now, even though that's not a major part, I have some short answer questions. One of them would be a double replacement reaction. It'll say, write out the balanced equation. Write out the complete ionic equation. Go along with it. Write the net ionic equation. See? That's one. Another one is, I'll give you one of these. Write out the half reaction for oxidation, the half reaction for reduction. That's a short answer, we have to show you work, but you might see a multiple choice question though, it'll ask you about net ionic. I'll do the shortcut, I'll do my shortcut, do the ionic, the other ionic. Here, they might only ask about who got oxidized, we only have to come up with this part in the multiple choice part. Another multiple choice statement has those drawings, like let's say we have carbon dioxide. And I'll say, draw the dipole moments, and then tell me if there's a net dipole moment. So I need my electronegativity on that.
so carbon is 8.5.
See, each of these were polar bonds, but the molecule is not because they cancel out. And I'll use the same examples in the book. You'll have, they use ammonia, they use water, hydrogen fluoride. And if you just go through those and look at those, you'll say that's pretty much how. One was a tetrahedron, remember, that's hard to draw a tetrahedron, but it's got a triangular base.
Yeah.
It comes up like this, and then one atom is actually in the center. You might have H, and like CH3 is like 3H4. I mean, methane is like that. But what's going to happen, whether or not they go in or out from the center, if that goes out, that goes out, that goes out, that goes out, it's going to be zero. If they go in, they're all going to be zero.
Okay. And then so we found the difference of the.
And I'll just say, some books don't like to put an actual line, but somewhere around here, even some books say you gotta be zero to be 100% covalent. I get it, I'm not 100% covalent, so I'm slightly polar, And then some books will draw, I have one book, 1.7, I think your book looks like it's more like 2. And you cross that barrier and you're so polar that you're gonna be ionic. And here you're gonna be polar covalent.
This one was in the middle.
And there's a lot of those.
And then you'll give us this one.
Oh, yeah. And then here is truly 100%. All your diatomic elements or things like that, they have to be 100% covalent.
And then what about the hydrogen bond?
Okay, so water is a polar molecule, which means that it does have a net dipole moment. The negative electrons will spend more time here than here. So the book says it has a partial positive charge here, partial here. These are polar covalent bonds, and the molecule is polar, because the net dipole moment. But now, hydrogen bond, I didn't even mention hydrogen bond yet. Let's do another one. Now what happens is, because I'm polar, this end of me, this is intramolecular, within the same intermolecular. And so there's intermolecular bonding. This end of this water is going to be attracted to here. So it might even slide all the way over here. And that's hydrogen bonding. And hydrogen bonding is why water should not be a liquid at this temperature. It is. And that's that extra bonds that have to be broken. And that's what makes water a liquid. It's
So
still
the
a
bond between these.
this end of the water and this one, another water. And that's what causes surface tension. That's what causes water not to boil. Why does it boil? It takes all the way to 100 degrees. Whereas things like CO2, which are, this molar mass is 18, right? This guy is heavier. Heavier things can move slower. If anybody's going to be a liquid, it'd be me. But I'm a gas. You should be a gas. I'm not. Hydrogen bonding. And hydrogen bonding is why you dissolve things so well. But what if you have something else that's polar, like alcohol or sugar? Polar likes to dissolve polar. What if you're a sodium chloride? Well, that's so extreme polar that we're plus and minus, and you're plus and minus. So my minus will be attracted to all those ions and I'll rip you off. And then this end will be attracted to that. It'll dissociate the ions.
And that's why we have a strong acid and a strong base.
And this non-acid, but it is an ionic compound, and 100% of it will turn into ions. That's a strong electrolyte. But all acids and bases, there are only 3 book point use. Well, they have 4, but they have 3 strong acids: nitric, sulfuric, and hydrochloric. And so when you put them, acids or bases by their nature, their definition, have to be a solution of ions. This is a solution that contains these kind of ions. And because all of those are strong acids, meaning they completely dissociate, if you put electricity to it, they're also a strong electrolyte. I'm not an acid, but 100% of ionic compounds dissociate. I'm a strong electrolyte.
That's why the light bulb.
Yeah.
The brightness.
Now, they gave one example of an acid that was not very strong.
We need to know which one's which.
Well, they only gave one example. This was a weak acid. What was a weak acid? Do you know what that is? HC2.
That's which book?
Acetic acid. That's acetate.
Yeah.
said only 1 out of 100 of those will dissociate. Well, then, if it's a weak acid, it's also gonna be a weak electrolyte, because there's not very many ions in there. And I think in the base world, pretty much a lot of your metal hydroxides, even though metal hydroxide, lithium hydroxide, potassium hydroxide, those are all, those are the typical 3 strong bases. They're more, but and they only mention 1 base, and this is weird because it doesn't have any hydroxide in it. But so these would like the glycol look bright. This would be dim. So strong base, strong electrolyte. Weak base, weak electrolyte.
And that's like when dissociation, when it like breaks up into ion.
Right, and so what happens is, what's the tendency of this, and what happens here, when you put this in water, it rips away one of the H's of water. And so the water gets ripped into OH and H. And then the H comes over here, forms an ammonium ion. And then they have your OHs out here, and that's what makes the base. But guess what? Only about 1 out of 100 will do that. And the rest of them will go back and form ammonia. Even some of these will go back, whoop, I'm going back to ammonia. And if you study thermodynamics, if you study, you'll figure out that some things, there's a tendency to want to go this way, they say go to the right, and some reactions that tend to go to the left, and if they're, some are equal, reversible, completely reversible, and some are not. Some are heavily go to the right, almost uphill. This one tends to go to the left, meaning no hydroxides, almost no hydroxides for you, except for you. You won't go back and do that. Same thing here. Oh, see you guys, no, I want to make some hydrogen ions. 1 out of 100. That's all.
And then neutralization is when the polarity doesn't.
No, that's where neutralization would be an acid base. Like let's say base acid here. Acid, and let's do the common base. And so what happens there? Those are double replacement. Remember that? And by the way, in double replacement, nobody's charge changes. The driving force is not gaining and losing electrons. It's either, in this case, the formation of what? Water, and you're going to salt. In this case, it's not sodium chloride salt, it's sodium nitrate. Now, if you look this up, you see that's aqueous because all sodium salts are soluble, all nitrates are soluble. And this is going to be liquid water. There's my driving force, and this is already aqueous. By definition, all acids and bases are solutions. Then, if you were to do the complete ionic, you get H plus, NO3 minus, Na plus, OH minus, H2O, Na plus, see that? And then I cross out all the spectator ions, and guess what? Get your little buddy, the net ionic equation for acid-base neutralization. If you have the same number of moles of that as that, then everybody got turned into water, which is neutral. And that's why it's called acid-base neutralization. Everything. Now, if you have to have more acid than OH, then it's not neutral yet. It's still going to be acidic. Great questions.
Yeah, because on the quiz, that was the one question I was confused about. I got it still, but.
That one, you could have used the acid-base neutralization equation.
Yeah, that's what I did. I think.
Or even if you didn't use that,
I used it.
yeah, you could use that. Now, there's a trick though. The trick is, no trick on this one, because guess what? For every one of these, you can only get one of those. So whatever the molarity of this is, it's the molarity of this, it's the molarity of that. Look at this. For every one of these, you only get one of these. So I can use 1.2 for the molarity of acid.
But say,
How do you miss it? You can miss
yeah,
that.
I was confused. I wasn't sure about that. I still got it.
Yeah, even if you had written it out, like stoichiometry problem, as a balance equation, you would have gotten it right that way too. This was just a shortcut.
And then say that was.
Now, if there's H2SO4, the molarity of the acid would have been 1.2. What's the molarity of the ion that makes you an acid? Would be 2.4, right?
And that is.
And this one, what if they've been barium hydroxide? Then, well, I don't have molarity. Let's say it's 3 molar. 3 molar barium hydroxide, what's the molarity of the hydroxide ions? 6 molar.
And then that would
trick about using that equation. It's not really the molarity of the acid, it's really the molarity of the ion in the acid. This was a very conceptual question. You got every one of mine. That was good. Yeah, that was really good. You were one of very few people. Maybe one or two people got 60. A lot of people got B's on this, some C's. You write this up. That. Any mistakes? So you understand the conceptual idea also, right?
Yeah, this was.
It didn't even matter. 10 milliliters. You know what? It's the same concentration. Now this is the only time you actually use the 10 milliliters. And then you got to be tricky because, ready? For every, oops. Okay. Actually, aluminum sulfide, Al2S3. Okay? Not sulfate.
Yeah, I can.
But you know what? Even if you thought of sulfate, you probably could get the same answer. But Al2O3 or S3. Anyway, so for every one of these, you get 1, 2, 3, 4, 5 ions. And so whatever the molarity of this was, the molarity of the total ions would be 5 times that number. And then the molarity times volume gives you moles, right? So if I ask for moles, say find out how many moles of this, and then multiply it by 5. That's how many moles of ion. Man, if you can do that kind of stuff as a high school student, and you're going to forget a little bit. You get back into chemistry class even next year, and that comes back to you, you're going to just go bang, 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 bang. You're going to be banging down.
I think that's all the questions I have.
Okay. Those are great questions.
Thank you.
And like I said, there's some in here that I know one of them is worded so poorly, and he does a great job most of the time, but one of them is just so, I should have just crossed it out.
Okay. Thank you so much.
Oh, you're welcome.
And then we can ask you questions tomorrow during lunch.
Yeah.
Right. Okay.
Now, let's see here. Wait, I thought you guys were finishing it during lunch.
Well, you said we.
You could, so what is your choice? Morning lunch or lunch and after school? What's your choice?
We can do it in class.
I'm just, it might be difficult to finish in just 55 minutes.
Yeah, I was probably gonna do like class and then after school.
You can do that.
Yeah, and then ask you because I have AP both.
Okay, I can do that.
Because I can't come in and ask you.
Okay.
Or I can come in during break. That way.
It's up to you. Just for yourself, I think some of you, like Caleb, he takes tests very fast.
Yeah.
Right?
Yeah.
He probably will finish it in 55 minutes.
Yeah.
But there's no way, some people in here, you're gonna take your time,
Yeah.
you're gonna say, no, I'm gonna take my time.
Yeah.
I'm just giving you the option to have an hour and a half, to take this.
Because if I rush it, I'd probably careless mistake or something.
Right, so, and it is intense in a way that in the multiple choice part, if you go to the next problem, okay, I'm gonna do that. Next problem, oh, dilution problem, oh, that's a base. And say, how quickly can you get, say, I know that, I know what that is, I know what that is. Okay, and you just gotta keep it up.
Yep. Thank you so much.
You're welcome.